Aircraft structural members are designed to carry a load or to resist stress. In designing an aircraft, every square inch of wing and fuselage, every rib, spar, and even each metal fitting must be considered in relation to the physical characteristics of the material of which it is made. Every part of the aircraft must be planned to carry the load to be imposed upon it. The determination of such loads is called stress analysis. Although planning the design is not the function of the aircraft technician, it is nevertheless important that the technician understand and appreciate the stresses involved in order to avoid changes in the original design through improper repairs. The term stress is often used interchangeably with the word strain. While related, they are not the same thing. External loads or forces cause stress. Stress is a material's internal resistance or counterforce that opposes deformation. The degree of deformation of a material is strain. When a material is subjected to a load or force, that material is deformed, regardless of how strong the material is or how light the load is. There are 5 major stresses to which all aircraft are subjected: tension, compression, torsion, shear, and bending. Tension is the stress that resists a force that tends to pull something apart. The engine pulls the aircraft forward, but air resistance tries to hold it back. The result is tension, which stretches the aircraft. The tensile strength of a material is measured in pounds per square inch and is calculated by dividing the load required to pull the material apart by its cross-sectional area. Compression is the stress that resists a crushing force. The compressive strength of a material is also measured in pounds per square inch. Compression is the stress that tends to shorten or squeeze aircraft parts. Torsion is the stress that produces twisting. While moving the aircraft forward, the engine also tends to twist it to one side, but other aircraft components hold it on course. Thus, torsion is created. The torsion strength of a material is its resistance to twisting or torque. Shear is the stress that resists the force tending to cause one layer of a material to slide over an adjacent layer. 2 riveted plates in tension subject the rivets to a shearing force. Usually, the shearing strength of a material is either equal to or less than its tensile or compressive strength. Aircraft parts, especially screws, bolts, and rivets, are often subject to a shearing force. Bending stress is a combination of compression and tension. The rod has been shortened, compressed, on the inside of the bend and stretched on the outside of the bend. A single member of the structure may be subjected to a combination of stresses. In most cases, the structural members are designed to carry end loads rather than side loads. They are designed to be subjected to tension or compression rather than bending. Strength or resistance to the external loads imposed during operation may be the principal requirement in certain structures. However, there are numerous other characteristics in addition to designing to control the 5 major stresses that engineers must consider. For example, cowling, fairings, and similar parts may not be subject to significant loads requiring a high degree of strength. However, these parts must have streamlined shapes to meet aerodynamic requirements, such as reducing drag or directing airflow.